be easier. So here is our max patcher. And I'm going to make a new object. I press the letter N to make a new object. In Jitter, you can actually press the letter J, and it'll pop up with a jitter, all the jitter objects. It's typically not what I do. It does pop up with jit.matrix, which is kind of convenient. So let's use that. And the way these jitter object works, did I say that correctly? The way these jitter objects work is that oftentimes they're just a bunch of attributes as opposed to arguments. So when we've looked at max before, oftentimes we'll have to put in numbers here or something, arguments, in a particular order so that the object works right. And you can do that with the jit.matrix. So for instance, the arguments of it would say, how many planes is this matrix? So we might say, well, it's 3 planes. What type of data is stored in it? And this is a little bit confusing, actually, but there's really probably only 3 you'll use, and actually only 2 in the end. But in the case of a color matrix, colors on the computer, in this sense, are only represented by numbers 0 through 255. So if I want a lot of red, I give red 255. And if I want no red, I give red 0. So there's only 256 numbers possible. And that can be represented by an 8-bit number. That's all kind of techie. It just means that that's why I'm going to type the word char in here. So char stands for character, and is what characters are normally represented by, like A, B, C, D, all those. But what it really means is just a number that is represented by 8 bits, which gives us 256 values. So for whenever you're doing video, just use char. And then what follows that is the dimensions of this. And I'm going to make it, let's make it 4 by 1, which is actually a one-dimensional row. And I'll show you what I mean by that. Now, so, another way...
Dr. Thompson?
Yes, yes.
Now, this always confused me. So you say the dimensions are 4 by 1, but isn't the dimension 3? Because there's 3 planes?
Well, that's a great question. Let's let that play out. Okay, so this is one way to make the matrix. Here's another way, jit.matrix. And like I said, it's all attributes. So I can say plane. Now I don't have to go in order, but I will. Plane count 3, type. And you can see these kind of popping up right here. Type, char, dim, what did I say, 4 by 1. That's another way to write the same thing, if you can't remember what order this goes in. And like I said, it doesn't have to go in this order. And sometimes it's useful to type out those attributes just so you remember what you're doing. This looks a little vague. All right, so to make a matrix output anything at all, we send it a bang. So I press the letter B for button, which gives me the bang. And let's look at what it actually gives us when we do this. It's not going to be very informative. Okay. So I hit the bang here, and it says JIT matrix U936008745. Okay, well that told me nothing about what was in that matrix, did it? It told me the name of the matrix. So let me name it something more intuitive. And try it again. And now we see my matrix is named Intuit. So for those of you that are into this sort of thing, and those of you who aren't, you can just tune out for a second. This means that there is a memory space in the computer for the matrix. And that what's happening is that we either pass into an object a matrix and we pass it by its name. So we're actually passing sort of a reference to that matrix. And that's how things get passed around, is actually passing the name of a memory space rather than passing all the memory itself. Because the matrices can get kind of big. So if you pass around that kind of memory, your computer really slows down. So instead, it's just passing a location of where the memory is. So now you can tune back in if that became too computer science-y for you.
Is that kind of like a buffer?
It's more like pass by reference. But yeah, it's like a buffer. So for instance, here we've declared that this is a 3-plane character matrix, dimensions 4 by 1, which means it occupies a certain amount of space. And And how much space that occupies is, I don't know. I'm not going to worry about it. But if I want to move it somewhere, or I want to tell someone else how to get to that information, I just say, well, why don't you go to where that memory is? It's kind of like if I live at a house and I say, you can visit my house. Why don't I just pick up my whole house and bring it to you? And you say, no, no, no. I'll just go to wherever your address is. Just tell me what your address is, and I'll go to your house. and I'll steal your furniture. Okay, so now we have this 3-plane character type 4x1 matrix named Intuit. And when I printed it out, it gave me no good information. So how do I get good information? 2 ways, 3 ways. Jit.print will actually print out what's in this matrix. So there it says 000, comma, 000, comma, 000, comma, 000. So we see that there's 1, 2, 3, 4, 4 cells, and each of them have 1, 2, 3 planes, 3 values in them. So let's look at it in a more visual way. So jit.cellblock will show us some stuff, but we have to tweak it a little bit. All right, so here we go. We go boom, and there's 4 zeros. So this is somewhat correct, but there's something a little amiss here, right? Because if we look here, we had, well, what happened to our 3 zeros? There's only 1 0 in that cell. There's supposed to be 3. But we have to imagine that this cell block here, it's kind of like it looks like, can I do it? It kind of looks like this, right? They're actually layered. So there would be a 0 here, a 0 here, and a 0 here. In the plane idea, right? But we can tell this jit.cellblock which plane to look at. So right now we're looking at the first plane, which is the R, the red plane. And we could tell it to look at the second plane, which would be the green plane, which will have the same values right now. Or we could tell it to look at the blue plane, same values. Or what's really nice is we can just say, why don't we look at all of the planes together? Ah, great. And so now I get RGB, 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 RGB.
Does it start with plane 0?
Yes.
Okay.
So the red plane is plane 0. So for me, I prefer to look at the cell block in this way. So all 3 planes are kind of listed how I think about this. Like, well, that just means that there's 3 values in every cell. That's what the planes means. The plane means. And then the dimensions mean how many cells are there. So let's look at what that looks like actually if we're not thinking just mathematically or numerically. I want to look at this like, well, how does that look? So here we have jit.p window, a patcher window. And this allows us to display what's in a matrix. In this case, right, the way that displays work, the ones we're looking at right now, is that they are just a collection of pixels. So pixels across the x-axis, the horizontal axis, and pixels across the y-axis. It's basically like cells, right? So on my computer right now, there's probably 1920 by 1080. So 1,920 cells going across the x and 1,080 cells going down the y. So every pixel becomes a cell with, let's say, 3 planes in it. An RGB so that that pixel turns a certain color. All right, so right now, if I were to bang this matrix out to the P window, with values of every cell being all 0, what color do you think will show up here?
Black.
Black. It won't change at all. So there it is. We see now what the matrix looks like. It looks like a black, 4 cells of black. Let's change one of them. Okay, so the way we can change stuff in a matrix, there's numerous ways, and I'm going to get to them, but I'm going to start with the simplest thing possible. So we can send a message, and I type the letter M to get the message. Set cell. And you've got set cell 2D, set cell 3D, and all this stuff, and they're all variations of this generic set cell. So we say, which cell do we want to set? I put down that it's a 4x1, so I kind of have to specify things in that way. If I want to change what the first cell is, let me make this look more like 4x1. So there's going to be like 1, 2, 3, 4 there. So the column, and then this is the row, is the second one. So if I want to change the very first cell, where is it in X and Y?
1, 1?
It could be 1, 1, right? But that actually ends up being the second one because we're counting from
0, 0?
Yeah, so 0, 0. So the 0th column and the 0th row is this first block right here. And then because it needs this, you have to say the word val for value. And then we get to say, well, what do we want the value to be? So let's make the color green. How would I make a bright green? What values do I put in here? And just so you know, these values are the values of each plane.
It'd be like 0 or 0, 255, 0.
That's right. That's the brightest green we can get. So let's put that in. And just forewarning, so you're not disappointed, this won't actually turn any color. Right. So we did set the matrix, but we didn't output the matrix yet. Matrices need an impetus to be output, and that is this bang, right? So now I can send the bang, and there, it turned the first cell green, just like it was supposed to. If we wanted to turn it a darker shade of green, we could use a darker green here. Oops, there we go. So now it's a darker sort of green. Or maybe I want to combine it with some red.
And will it divide the window that you have in whatever 4x1 is?
That's right. Yeah. So that's an interesting question, because how does this P window know to do what it does? Well, that's because it's part of this jitter environment, right? There is something happening when I send a particular matrix to this window where it knows to do stuff. So I can expand the window like this, right? And it's uneven. It just fills in, it basically turns this window into the matrix you've specified. Let's set a different cell. So let's set the last cell. How would I change this message to set the last cell to a color?
3, 0, val, number.
That's right. So I have to say, okay, this is the 0, let's see, 0, 1, 2, 3. Great. And then it's got 3 values in it for the planes. And we'll choose some random number. And in the interest of not having to hit the button all the time, I'll put a comma here, which means make a new message, and just send a bang like that. So now I can just bang it through. All right. And to keep going, right, we could fill the rest of them in this way. There we go. So now there's our matrix, and we see it represented in the following ways, right? We have this cell block where I send it a message plane -1, which shows me all the planes in a single cell. I use the jit.print, which will actually just print out all the matrix numbers so you can see them. And then I have the jit.p window, which is actually sort of a experiential way of looking at the data, right? We can see, oh, okay, well, there's 4x1. Each of these is set to a different color. Right. To beat the horse dead a little bit, let's change this. And now I'm going to make it have 2 rows and 4 columns. All right. And so there we go. So now we've got on the first row, right, the 0th row, the second column, or the first column, we put this, right? So this is kind of the trickery you have to do to deal with this, right? Is if we were going to try to make images like 1920 by 1080 images ourselves, this is basically what we would have to do, which seems probably not the best way to go. Seems pretty slow. Okay, so let's carry on, and I will set the one right below it to a different color. There we go. Right, so there I set the first column, the first row, which is actually the second row, to a color. All right, so I'm going to abandon that for a second while you figure out a question you would like to ask. Are there any questions about this? I think it's really clear to me, but maybe it's not clear to you.
The only thing I don't quite understand is the different matrix being shown. So that's not the different matrices being shown. You said that's experimental.
Experiential. Right? So we actually get to see the data here in its rendered form, right? So instead of looking at numbers, we're looking at colors. That's what I mean. We use our eyes kind of to say, oh, okay, well that looks like this data. That's what the data looks like, as opposed to that's what the data is. And it doesn't mean anything. It just means like here we're looking at what that looks like as an image. Here we're looking at it as what it looks like as a bunch of numbers.
That is either plane or of all the planes together.
So this is all the planes together because that's how we make colors, right? We have to combine red, green, and blue.
Okay.
Well, there's actually other ways to do it, but that's a simple way to think of it.
Okay.
Okay, so I put on Folio for you guys this zip file, so you can study that on your own, and I put that in the, why don't I just download that? I put that in the Folio checklist. There we go. I got the word. In the Folio checklist, and so you'll be able to download that and look at it, as we will do here. Okay, let's see, where do we want to start here? Let's start here. Okay. So this is the same sort of thing. Here, check out, let me blow this up a little bit. All right. So notice that I've named this matrix grayscale with an E, curiously. And it is a one-plane matrix that's a character matrix that's 4 by 4. So we would expect there to be 16 cells here. And when it's one plane, the way that the window interprets it is as, well, that's just gray, right? We don't have enough information to make this have colors. So what will happen here is as I change this number box, the $1 gets that number and passes these messages, the set cell 00 val $1 and the bang following it.
Dr. Tom,
matrix. Yes.
Does the P window just always do RGBA? Like, does it just know to do that with the matrix?
It does ARGB, but you can specify it here with the color mode. You have the choice of ARGB or UY VY. I stick with our ARGB. I understand that really well. Okay, so as I increase this number, what do we expect to happen?
The 00 cell is going to change to white.
That's right. So here we go. We're bringing it in. There it goes. So kind of a grayscale idea. So here, right, there's only one plane, so the window interprets it a certain way. Now remember that this matrix is just a data structure. So the window interprets matrices in a certain way, but we can hold whatever numbers we want, and they don't have to mean anything visually for this, right? But for the next few weeks, we'll be doing this with regard to how things look as a 2D video. Okay, so there's actually 16 cells here. We have 4 columns and 4 rows, and we could set any of those we wanted to. Same sort of way. So let's do the last one down there in the corner, and we'll make it that color. Okay, so that's that. That's one way to do things. Over here, I wanted to show, here's a movie, right? And remember, we find our movies kind of over here on the window, or we can drag one in. So a movie, right? Let's see what it looks like without too much manipulation. So here's our window. And we look at the movie. It looks like this. It looks like a bunch of dishes, right? Can loop the movie. And here the window is assuming this matrix of pixels is the size of the movie. So that's probably, you know, 720 by 480, or who knows, some number of pixels. But I can kind of downsample that and put it into a 4 by 4 matrix, and this is what it looks like, right? So now we get sort of a quite pixelated version of this movie. But it does make a nice table mat. And we can pass messages to this matrix, things like get cell. So what's the value now at cell 0, 0? And it tells us, like, well, that color right there is actually alpha 255. I'll talk about what that means in a second. Red is 85, green is 73, and blue is 62. And there's some mysterious alpha thing there.
So it's dumping from the jit.matrix into that message box?
That's right. It's kind of another way of, we could look at it again with jit.cellblock, which I like. Plain -1. And we could send a bang to this matrix, which is still holding this last image, right? Oops. And there we would see the numbers again. Let me change the column width so we can see all of them. So here I go to the inspector and change the column width. And there we see the same numbers, right? 255, 85, 73, 62.
Can you set the plain number as an attribute in the cell block instead of having to bang in a message every time?
No. Which is really unfortunate.
Yeah.
I tried that and it did not work out so great. Okay, so that's a thing, right? That we might choose to get our information to populate a window from something a little bit less basic, right? In musical terms, like, this is kind of like using found sounds to work with, as opposed to synthesizing things with sine waves from scratch or something like that, right? We can start with something instead of nothing, and sometimes that makes our lives a little easier.
I have a question. How does it know which colors to put there? How does it downgrade the number of pixels? Or it just takes whatever color was in pixel 0, 0, and then, I don't know, 125, 0, and it just goes?
That's a good question. Let's find out. So the way I'll try to find that out, my guess, because I don't know the answer, my guess is that it interpolates between a bunch of values to downsample it. But I don't know that for sure. So let's look at what comes out of here. And I won't loop this. And then let's look at what comes out of here. And So it looks as though it just takes, let's see, so it looks like it took directly that first pixel. So actually what we're seeing here is the very first pixel of that Dishes movie. And then it doesn't take directly the second pixel. It's probably going to divide this, right? So we'd have to go way down the line to find this 2610. It's just going to kind of sample the matrix there. I don't know if I'll be able to find it. It's a lot of values. Getting closer. So to answer your question, what it appears to do is not interpolate, so that would not have been the correct answer. It appears that it just grabs the pixel that would be whatever the x value, the number of pixels in the x axis is for this Dishes movie. It looks like it divides that into 4 and just finds the, at 0, if there's 100 pixels, this would be 25, 50, and 75, or something like that. Does that make sense? Yeah,
Yes.
that's what it does. Okay, right, we've got this again, which we've already covered, and that's it for the matrix info. So the only thing we really glean from this is grayscale is possible with one plane, and we can actually feed in a matrix full of information like a movie and populate a matrix in that way too.
Could you do gray in using all 3 planes?
Yeah. How would I do that?
You move all values by the same amount, like
That's right.
0,
That's
1,
right.
1, 1, 2, 2, 2.
So this is the same as a 4-plane matrix.
The first one being the alpha? Or
Sorry. Yeah, 3-plane matrix. Let's do that. The first one would be alpha, but I just don't want to put it in. And then what we could do is we could say set. Oh, well, I could just do it with 3 different values here that are all $1.
So does that mean that like black and white video takes up less memory than color video?
I don't. Well, maybe it depends. I'm not sure about the answer to that either. You could, right? In this case, I think a black and white video will actually be a 4-plane video, and just all the planes will be the same values. You could reduce that to a 1-plane matrix in Jitter and save memory, because you don't need to operate on all 3 things if they're all the same. But I'm not real sure what's happening under the hood there. Okay. So let's take a look at something a little more. We'll step up an advancement this way. So this is a little too much to try to conquer in this particular class today, but I will step through a little bit of it. And if you feel a little bit confused with this little ramping up of information, don't worry about it too much. This is something maybe you can study offline. But there are lots of ways to set the matrix data. So we did the set cell thing, and that's cool, but it seems a little slow. Here I could set all the cells to these 4 values, right? So here we have a 5x1 matrix with 4 planes, ARGB. And I'll show you what alpha means soon. And here I set all the stuff to the same value. So I can just set my whole window, my whole matrix, all 5 cells, to these values. Let's set all. And we can find all of these by looking at the matrix messages. And we would see that there's all of these different things. There's set plane 1D, set plane 2D, set plane 3D, set all, set cell, so forth and so on. There's these sort of things. Here's fill plane 0, so the 0th plane, with a value of 255. So that's alpha. Doesn't mean anything for us right now. Fill the red plane with 255, fill the green plane with 128, fill the green plane with 128, fill the blue plane with 64, right? And it does it for all the cells, and we turn that color. here's the set cell 2D, which I said is just a variant of set cell. So set cell requires me to put val, and set cell 2D does not require me to put val. Same result, right? So here it's the same thing. And those are sort of just variants on what we just did. Now, some real power, and actually the forward-looking aspect of this, is that we can use expressions, mathematical expressions, to fill in matrices. And this is a little bit advanced, but it's going to be kind of important for you to know in the end. So here I'm using this experfill message, but you can find a lot of this stuff in jit.exper, which does the same thing. Evaluate an expression to fill a matrix. So that's kind of what I'm doing without using this object. So if you want to get the help with jit.exper, you might find some cogent information. So here I say this really weird looking thing. I mean, it looks like rocket science or something. It says experfill, which is a message I send, and then I have norm square bracket 0. What? So the word norm here means, like when we normalize audio, for instance, we normalize it so that we put it between 0 and 1, right? The highest value will equal 1 and the lowest value will equal 0. Here, what we're saying is for the to make values that go from 0 to 1 evenly over the matrix on the x dimension, on the x-axis. If I did S norm, that would mean signed normal, which would go between -1 and +1. So that doesn't make any sense for our colors. We go evenly here. Now, I said 0 to 1. Aren't these values between 0 and 255? So this is a thing that happens in jitter that we just have to be aware of and kind of work with, is the fact that it will normalize between 0 and 1, and then this character matrix will take care of the fact that 1 actually is 255, and 0 is actually 0. So it just kind of scales it for us. But we speak to this matrix in terms of being between 0 and 1. So here's another experfill thing that says whatever's in the matrix right now in X, add 1 to it. Add 0.1 to it. So theoretically, all of these should get brighter. There we go. That's another way to do it. And there's some ways we can perform operations here. So the operator divide by 2. This isn't the way I normally do things, so grain of salt. We can change the matrix this way. So when we want to fill a matrix in complicated ways, sometimes we need to use these expressions, because often we just want a matrix to look a certain way or to fill with a math idea. And we'll get to that more in just a second.
Excuse me, sorry, can I ask? So like with the sort of language of this norm square bracket 0 square bracket, is that like meant to convey like the entirety of the array, which is in this case a matrix? Is
That's
that right?
right. So here we have a matrix is really a two-dimensional array.
Yeah.
So it's got columns and rows. And here if we say the array, the two-dimensional array at the first dimension, we're talking about the columns.
Mm-hmm.
If we say it at the second dimension, 1, we're talking about the rows. Here, since we only have one row, it doesn't make a lot of sense. Let's do a 3-row thing. And now they're all the same. Let's see what happens if we put this on this one here, and it goes down this way.
Oh, okay, cool.
Or I don't know if it's possible. Maybe it is. Maybe it is. Can I just do? I don't know if I say 0 here, or if I have to make another norm. Yeah, I have to make another norm. So
You wouldn't be able to do like 0, 1 instead of the square brackets.
No, it wouldn't work.
Oh,
like
okay.
Anyway, I don't want to get off on too much of it.
Yeah, sorry.
And here's some more about expert field. So norm 0, norm 1, and what I just said. S norm, that's not actually true. Glad I saw that. So it's -1 to +1. And then, yeah. And like I say here, it can all be done more completely with the jit.expert object, which is actually where you should look for that. So this matrix over here was named fill me. And you'll remember that I said earlier on, I said you don't have to pay attention to this, but now you actually kind of do, that this matrix is named, so we're actually pointing at a memory space, which means if I make another matrix name the same thing, right, it actually is holding that same information. So without having to send this from here to here, that's what it is, right? If I make another matrix called jit.matrix fill me, it's the same memory space we're pointing to.
What does it do if you were to give that second jit.matrix fill me values or attributes?
It would change the values of that memory space, and there's only one memory space. So it would actually affect every matrix object that references fill me.
Yeah. So whichever one is banged first would get the values out first, and then the second
Yeah,
one that'd be
it's going to
banged.
manipulate the values kind of within this object, and then whichever one bangs first is the first one you'll see, but they'll both be the same information. Yeah. So here it looks like I'm using this Uzi object. So the Uzi object, as you will remember, sends out a bunch of bangs at once. I don't know why I went to a counter here. I could have just used the index, but I didn't. And then I'm getting the cell value here, and looks like I'm just trying to get the cell values. Whatever, that's not super important, but the Uzi part is. And here you'll see the two challenges that I put in Folio for you that you will need to do as homework. So the one that is absolutely necessary is you will create a matrix that has 4 planes. Maybe it could be 3, but let's say 4. So that's ARGB, right? And A should just always be 255. But if you don't make it 255, it won't look any different. So whatever value you put for that first plane is fine. And then RGB, that matters more. It uses a character data type and has dimensions that are 11 by 5. Make it display a red cross. So an even cross, like that, like an X turned 45 degrees. That's the homework, right? So to do that, there are a few different ways to do it, but set cell makes a lot of sense. But the way you do it is that it should actually make that cross when I open the patch, if possible. So if you might brute force that with a whole bunch of messages. You might figure out a way to do it that's a little more clever, but whatever way you figure out to do it is fine. And then the bonus track is create a matrix that has 4 planes, uses the char data type, has dimensions that are 11 by 5. And it'll display a vertical line down the middle of the matrix. And the values of that will vary according to a sign function. So you may not even know what I'm talking about right now, but that's okay because I'm about to show you. Okay, so we did that. Okay, I'm looking at the class one now. This is the one I made for today. Let me close some of these other things out. All right. So let's look at the very top one here. And I labeled this. Let me zoom out a little. Setting an ARGB matrix by hand, viewing the structure of the matrix. We've already done this, right? But just as a little reinforcement here and a little extra, I'm turning on something called a Q metro. So a metronome, YQ metro. So this metronome, unlike some other metronomes in Max, is not a high priority event, right? So in computer terms, like if my computer starts bogging down a little bit, this will be the first thing to kind of say, I'm not that important. My timing is not that important. Don't worry about me. And it's actually important that we use the Q metro instead of a metro here, because when we're drawing things on the computer, it's easy to crash if we try to put that into a high priority thread. It's actually not that important. that we draw with the same accuracy as we do musical events. I guess one could argue that it is, but I'm going to say it's not. So here, if I turn on that metro, now it's constantly banging out this matrix, and any change I make is directly reflected, right? So it's constantly getting that bang message. I don't have to send the bang message anymore. So here I set the second column 0th row to this value. It reflects here in the jit.cell block. We can look at plane -1 and see them all. And I've actually set this up in kind of a cool way, which may help you with your, or it may not, may help you with your idea of making a red cross. Like, well, can't I just type in the in this cell block thing? Like, isn't there a way I can just type here and just put the values in? That would be convenient. Well, not really, but there kind of is. So this object here is a text editing object, and I can actually type in the values here. So this one here is what, 126 for the alpha for some reason, 255, 0, and 0. So I'm going to make the one right below it green. I'll put a value of 255 for the alpha, 0, 253, a little darker green, 0 for the blue, and then it actually changes that and puts it back in. So there's a little trickery right there where if you're interested, you can kind of look and see how this worked. There we go. Let's look for a second at why alpha matters. So what alpha really does, like this alpha blend thing, is it allows me to blend two alpha channels together. So I have this, well, I don't know why I have this set cell thing here, but this is a black matrix, right? And I'm able to blend between this matrix and this other matrix with my alpha value. What that really means is that if my alpha value, let's say here, is 0, then it's going to do all of the other one, right? 0. It basically disappears, right? Because we're relying all on this black matrix. We've crossfaded to the other matrix. Whereas if I put the alpha here to 255, then we won't see any of the black matrix anymore. And if I put this halfway in between, we'll see kind of a blend of those two things. So you see how the black and the blue kind of combined. So that's what an alpha channel is. It's just a way that we can blend two different videos, if you want to think of it that way. Really two different matrices. We crossfade between them linearly. Okay, that's extra. So this is what I want you to really understand is, again, we're setting matrices. So let's now step it up a level. And how would I set a one-dimensional, one-play grayscale matrix with an Uzi? In other words, I kind of want to make a loop, right? I want to be able to loop through, in this case, all 10 cells and set them. So in Max, that's a little hard because there's not a for loop. And later, I will show you two other ways to do this that use JavaScript or use something else. But for now, it's good enough to say, well, what does Max do that will allow us to do this? So here's our Uzi, which is going to count from 0 to 9. To prove that point, let's print this. I'll disconnect the magic for now. Try to. So we'll print what comes out of this little outlet, which says it's the current index. And there we go. Make this go away. Oh. Okay. So if I hit this Uzi, it counts from 0 to 9. I proved it to you. So now if I hook this up to this trigger II object, that means that this integer, which at first is a 0, will come out this right outlet first and then the left outlet. And so when it comes out here, I'm going to scale what does go from 0 to 9 to 0 to 255. So the first one, 0, is going to give me a value of 0. The last one will give me a value of 255. The one in the middle will give me a value of 128. So basically, as I go along, I'm setting this value here to numbers that go smoothly between 0 and 255, which means my cells should go from dark to light. And which cell gets set is also part of that 0 through 9. So first, the 0th cell gets set, second, the first one, then the second, third, fourth, fifth, seventh, eighth, 9. And I'll turn on the Q metro so the matrix is always outputting, and then we'll do this, and we see that we go smoothly from dark to light, kind of using what is in Max a for loop. In other words, it counts from 0 to some number, and we're able to use that loop to do stuff. So this happens as quickly as it can happen. Puts out bangs as quickly as they can go. All right, so ask me a question about that, because that's a little bit stranger.
What happens when you use a line object? Does it like draw them in, or?
So if I used a line object to go from 0 to 9, that's a good question. Let's see what does happen. So line. And we're going to replace the Uzi, right? So there we go. And to make the line go, we say, go from 0 to 9 over, 1 second maybe? And let's clear out this matrix. So set all to 0. There we go. And now, so this line, just to prove it to ourselves, we'll print out what it does so we know what to expect. Oh, it's putting out a whole bunch of zeros. Okay, fine. And we'll hook this up here and we'll see what it does. Yeah, just like you would expect, right? That's pretty cool. And I guess at the end of the ramp, we could set all to 0 and then hit this thing again. Something like that.
Light show.
That's what I was thinking when I saw it. I was like, can you do that?
I guess you've got to be careful with the way that you count, because it seems like you can only use like integers for something like this, right? Like,
That's
like
right.
what is
Anytime
0.5 of a pixel, you know?
Right.
Well, that's true. I mean, but basically we're talking about a grocery list. So, you know, we have like oranges, apples, and fish, and you're like, well, give me the 1.5. You're like, I have no idea what's between an apple and a fish.
Official?
Appish.
Happish.
All right, so that's that one. So that's pretty simple, right? It's nice. Then I say, well, what if I have 2 dimensions? So this one was actually kind of hard for me to do personally, because I said, well, how would I do it so that it does the same thing, but we go from black to white over 2 rows? And let's turn on this thing and look at the result first. So there, I did it. Believe it or not, this is actually right next to this. So it's kind of almost like an optical illusion that doesn't even look like it's the next continuation, but it really is. And the way I do that is I have 2 loops now. So I have 1 loop for each row and then 1 loop for each column. So I say, all right, go through this row first 10 times, and then go through this row second 10 times. If I needed to fill a whole bunch of stuff, I could do it like that. But now you start to see like, well, I guess it's a very explicit way to do it. But maybe there's a way I could have done this in a different way with jit.expr or something, but this way works. And let's examine how it works. So here I'm saying for each row, and then I say multiply by 10, and then add each value here, which counts from 0 to 9. So what does that do? That says at first this is 0. So on the 0th, so it has a 0 here, add 0 to it, and then we count 0 through 9. So that gives us 0 through 9. And then on the first row, which is the second row, we add 10 to each of those numbers. So then we get 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So that's how I address each cell. And then we have to scale 0 through 20 to go between 0 and 255. Yes, Alex.
Can you do like diagonal in matrices?
Uh,
Or is it just like this wobbly goop that you have to go through to make that happen?
I'm sure there's a way. I don't know right now how I would do that. Because
Alright.
basically you'd have to address, how would you do that? You would say, oh yeah, it makes sense. You would just do it like, so let's say this is a one plane character matrix 4x4. And then to do diagonal, you just set the numbers the same, right? So 0, 0 would be our upper left cell, and then 1, 1 would be the one diagonally, 2, 2,
Sorry if this is a little bit off.
and then 3, 3. So you just have to figure out how to address the cells like that, right? This
Okay.
actually would be diagonal. It would look like that.
What I was talking about more of was like you have those two lines of varying degrees of gray or white, whatever,
Mm-hmm.
and you did diagonal, like so they meet up to a point, like they actually meet up in the middle, like arrows.
Mm-hmm.
So that's so. I guess you just do exactly the same thing.
Pretty much. I mean, if I were to do that, I would do it like this, where I say, well, basically that means both numbers are the same. I mean, you'd have to have some black part of this, right? So all the cells of the matrix, and it would have to be a matrix that's not just 2 rows.
Right.
It's more rows. So you'd have, whatever level of resolution you have is how thin your diagonal can be, or how much it actually looks like a straight line. It'll look pretty much, if you have this low res stuff like this, it'll look like an Atari game. Atari is a video game system from.
I know I have one.
Do you really?
Yeah.
Oh. Let me see if I have time to go on a tangent. I do. So I was telling Ryan about this yesterday, so I'll tell everybody that
Sure.
my kid does this thing in Minecraft. It's very concerning to me. 'Cause this is what happens to every generation. Your kid will find something to do that just drives you insane. Like, why are you doing that? You should don't do music. Do something real with your life. Well, he does this thing in Minecraft, which is extremely repetitive. Like, he builds a bridge from one place to another in as quickly as you can go. So it's like the difference between like 7.75 seconds and 7.7 seconds. This is what he's shooting for. It's just repetitive behavior. Well, I criticize that, but when I was a kid, there was this game, I think it was called Decathlon or something like that on the Atari.
Yeah, I know. Yeah.
And it's not a there's not a lot going on there with your controller. You've got like the joystick and you've got a button. That's what you got. And so to make the guy run fast, you just move the joystick back and forth as fast as you can, right? I spent, I don't know how many hours of my life perfecting that technique so that my guy who jumps over the pole vault, like, I can do it better than anybody else, or I can run the track in 9.9 seconds. And my activity was to do this, infinitely.
Do you know Space Jockey?
No.
Okay, never mind. That's an Atari game that I got really obsessed with. They're going on a tangent, but I love that game.
Anyway, so my favorite Atari games were probably, I liked Space Invaders a lot. No, not Asteroids. And Pitfall. And Frogger.
See, you all are lucky to have like Atari systems. I remember playing like Galaga on like a big arcade cabinet
Oh, yeah.
Oh, yeah.
That's a great game.
at the roller skating rink.
Oh, we had one in the laundromat near my house when I was getting my master's degree, so I'd go play
Yeah.
Galaga.
Oh, yeah.
Nice.
I also have another story that's pretty fun, but I'll tell you sometime when we're not recording. All right, so and I won't remember I said that. So when I do say, tell me about Big D's ice cream shop and the wheat penny and the wheat penny. That's the story. Big D's ice cream shop and the wheat penny.
I can't wait to download this in 20 years. I'm like, I don't remember that story.
You'll never forget the story when I tell it to you. It's
Okay.
part of my childhood. All right, so
It's on the test.
now that we've had a little mental break, Here is the idea of setting something with a sine function. So let's look at it so that we have some experiential data to examine. So here we see that it goes from 0 and up to 1, or 0 to 255 and then back down to 0, right? And it does it in sort of this smooth way. What's happening here? So before I do anything too crazy, let me just draw this. So I will do a new share, the whiteboard. All right, so say draw. Kind of thick. So here is a sine wave. That's what they look like. And normally these go from +1 to -1. So at the bottom we have -1, at the top we have 1. And the way we achieve this this action is that we go from 0 to 2 pi. So that's the circumference of a circle. Basically, we're going all the way around a circle here. We're doing the same thing as this. 0 to 2 pi, and we run it through just something called sine. So the sine of 0 is 0. The sine of 2 pi is 0. The sine of pi is 0. And so from the sine of 0 here to the sine of pi, and then all the numbers in between, we kind of get this smooth curve that goes up to 1 and then back down to 0. So if we just make something that goes from 0 to pi, then we can get this curve, right? And now our values for our gray matrix will be, well, start at 0, go to 255, and then back down to 0. Any questions about that? So basically I'm cutting off, all of this and just using this part of the sine wave. And there's a piece of math that does that for us. And the way that works, we won't worry about, but study trigonometry and you'll remember, like, oh yeah, that's triangles and stuff.
Can you not just divide it by 2? Sine divided by 2 would make it 0 to pi.
No, because remember we're taking the sine, for example, the sine of 2 pi divided by 2 would be 0. I don't think that would work. Maybe I'm wrong, but I think it matters here. It would have to be like the sine of 2 pi, sorry, I'm drawing it like this, divided by 2, like that, as opposed to this. But why don't we just go from 0 to pi? Because that's all we're really trying to do, is trying to get this, right? I don't want any negative numbers. All right, so let me go back to sharing this. Okay, so that's what I'm doing here with this sine object, right? So you see that I'm counting what was going from 0 to 1 is now scaled to go to 0 to pi-ish. I didn't want to type out all the numbers, so I just typed out the ones I know. So here I do the Uzi, which counts from 0 to 9. And to make that go between 0 and 1, I have to divide all those numbers by 9. So 0 divided by 9 is 0. 9 divided by 9 is 1. So that's kind of what's happening here. I take the sine of that, and then I scale what's going from 0 to 1 to 0 to 255, so I can set my cells appropriately. So I'll let you kind of study this. It's not complicated. It's exactly what I said. But if you were to try to do it without looking at this, that might be an interesting challenge for you. The challenges are numerous, right? They're, one, remembering how to set up the matrix, being one plane and how many dimensions. How do I set that with the set cell thing? How do I use an Uzi to kind of make a loop to do that? And then the extra complication on top of all that is, what does this sine thing do? When did I sign up for this class? Well, here we are. So that's that. So in that bonus challenge, right, you can kind of use this sort of idea to try to make a red stripe down the middle that changes its values according to a sine function. Okay, yeah, that didn't make any sounds at all. We will get to that at some point. Right now, we're just kind of trying to make sure we understand the very, very basics of what all of this is built on. Obviously, this isn't the way that most people will work, right? It's really hard to populate a matrix one by one. In the end, we will do other things. But to manipulate the matrices, even if they have data already in them, it's important to understand what's going on and why we see the things we see in the windows we're looking at. All right, ask me a couple questions.
I was confused why you're dividing by 9 in the sine function.
Yeah, why am I doing that? Let's see, I probably could do it a different way, right? I could probably say,
Looks like that's coming out of the bang, out of the button.
Yeah.
so yeah, this Uzi, right, is going to count from 0 to 9. And for some reason, I'm multiplying. Yeah, I mean, maybe it would make more sense to just say, well, just divide that number by 9. Yeah. Thank you.
Yeah, that makes more sense.
Yeah. Okay.
That makes more sense. That's clearer. Occam's razor, right? So now the number's being divided by 9. It turns it from being from 0 to 9 to 0 to 1.
Yeah.
And then once we're 0 to 1, everything's all happy, right? In general, with many things, audio kind of, but really graphics and math stuff, is 0 to 1 is a lot easier to work with.
Couldn't you not divide by 9 and just put it 0 to 9 in the scale object?
Yes.
Make it even simpler.
There we go. Now we're talking. Now we're really getting there.
This is
And-
pod racing.
Yeah, so there we go. That's good. Good optimization. I like that.
How we can potter.
And you know what would happen? I guess to carry on this thread, what would happen if I made this cosine?
Ooh.
It'd invert it, white to black or something.
Well, where would it start? What's the cosine of 0?
Well, the cosine of 0 is
It
1.
would, like, invert it.
Yeah, right. So it would start at the highest value, then dip down. Let me draw this. Let me. Okay, zoom is just okay. There we go. So I'm really glad it kept all that. How do I clear this? Clear everything. So a cosine wave looks like this, right? And that's down to -1. So if we only took the first half of this, we'd have to actually do something to deal with the fact that it's sinking below 0. We could just take a quarter of it, I suppose. A quarter of a
normalize it.
cosine goes
Or-
that way.
Or do you think you could account for that in the scale?
Yeah, that's what I was thinking.
Let's see. So what goes from 0 to 9 goes from 0 to... Yeah, I could say whatever that is divided by 2. Or I could just press the button and see what it looks like. Like, oh, it looks kind of like that. And we can see the result, right? We sink below 0, and now this is all...
It's still on the
Effectively
whiteboard.
You're still,
Josh.
you're still on
Yeah, you're still on the whiteboard.
Oh! Well, it doesn't look very good. Okay, sorry. So here I pressed the button, and this was the result, right? So we see it starts really high, and then it dips down. Now we're below 0. So it's just
Yeah.
black. You can't get any blacker than black. It's black.
You'd need another scale object or something to normalize
Well, I just
it.
need to... I need to rethink my logic there. Like, what are you trying to do? You're going cosine wave, and you want it to do what? Which would really mean probably like, well, you want that to be half. So that's like, what, 1.7-ish? 1.717? Yeah. It's still not quite right, but close. And
But
since we're taking a quarter of that cosine, right, our change isn't quite as good as that sine one was.
Right.
We're more gradual. This is a quicker curve drop off. Anyway, this is getting pretty a conversation about cosine and sines, and really what I want you to know is how to fill a matrix.
So, how do we fill it top to bottom? So we would use the column.
That's
Right.
correct. So here we say it's 1 by 10.
Mm-hmm.
And now we're setting, I think that's the same.
Wait. Why would you change the matrix itself when you can just say the column within the matrix?
Let's see, how many columns? Let's say there are 10 columns in this matrix here.
Right.
How many rows are there?
Oh, there's one. I get it. Okay.
So I need more rows, right, and fewer columns. So 10 rows. And then I would have to say set the 0th column first row and do it like that.
So if we're drawing a cross, right? So that means we'll have to use rows and use.
Yeah, you'll have a 2-dimensional matrix that's 11 by 5. And
Okay.
it's not 10 by 5 because you can't draw in the middle of a 10 by 5 matrix. You can only draw.
Can you draw? I guess you can, but can you draw saying only from this column to this column using the sine wave?
Only from.
Like okay, so you have column 1 through 10, and I only want to draw between 6
On
and
row 5.
Oh yeah, sure. Okay, so here we have. Let's go back to what it was. So 10 by 1, and here we're effectively doing this, right? It's actually more correct.
I don't know.
And you're saying, can I just not draw like these two or these two?
Right.
Right. So where is that happening? So here we do 0 to 9,
Mm-hmm.
right out of here, and it's the thing that says which cell we set.
Oh,
So
so
here,
we can
I can just say scale. What in the world? Okay, scale. What was going from 0 to 9, let's make it go from 5 to 7. Right, which is going to have some bizarre effects because I'm kind of counting on it drawing 9 things, but
that's what we're here for.
Oh, right, I have to clear the matrix.
Oh, if you don't clear the matrix, it like layers on top of each other. We said that before, right?
Well, I never set these values, right? I didn't set them to anything else. I just set 5 through 7 to something else. So I guess that's what that looks like. It's not really exciting.
I don't know what you're talking about. That's stupid.
There you go. So yeah, you have to decide which cells you're setting and then which values to put in them. All right, so with that, let's take a look at Folio, just so we understand how to work that little world. And as always, if you find yourself like a little confused by this, you should definitely give me an email without hesitation. Just throw me an email. I'll be able to help you. If I don't just lose your email off the first page and forget it exists, which happens. All right, so yeah, here we go. And here is week 1. This is not Tuesday, this is Thursday. Although on the Tuesday class, I did put up the video of the class, so it's there now. Took me a little while, I apologize. So here is the homework, week 1, day 2. So this is always where you should look, is kind of at the checklist. I try to put everything in the checklist. And complete the week 1 challenges and turn them into the drop boxes associated. I already told you what that is. The challenge is to draw a red cross. And then if you're up for the challenge, a vertical red bar that changes color according to a sine function. If you're not up for that, then don't do it. No penalty to you. Study. So I want you to look over these files that we looked at today. And the best way to study is to try to do these things yourself, right? It's like, okay, so I'm going to fill a 10 by 1 matrix so that it goes from black to white. How do I do that? How to make it go from white to black? Just try things, right? That's the only way to really do it. Watching me do it actually won't do it for you, right? You have to do it yourself. You have to fail at doing it and keep a joyous attitude in your failure and know that you'll get it and figure it out. And then there's one more tutorial I'd like you to look at for next week, and that's create a matrix, which will be a simpler review of what we just did, right? So there's a whole tutorial devoted to what we did, but it doesn't go as far as what we did. But it'll definitely solidify what you learned, and is written in a way that's nice. That's it. Any questions about what you're supposed to do? This week 1 challenge is due by Thursday. I'm trying to give you a week to do the Mac stuff. On Tuesday, we will not be talking about Mac stuff. We will again drift back into history and aesthetics. And then on Thursday, we'll have another Mac's pursuit.
Sick.
Awesome. Radical.
Radical dude.
All right, with that, I will end this. I will see you guys later. I will post the video and send you a link to it in mail and put it on Folio. See you soon.
Miss you already.